Okay, solve quiz 8. So basically this first problem was the nucleation part of the chapter 10. And for this we use R star equals negative 2 gamma Tm divided by delta HF 1 over Tm minus T, where Tm is the melting temperature of ice, which is 0 degrees C equals 273 Kelvin. Delta HF is that, which is negative 3.1 times 10 to the 8th joule per meter cubed. The temperature where we're holding the system and it nucleates is minus 40 degrees C, which is equal to 233 K, and the surface energy is equal to 25 times 10 to the negative 3 joule per meter squared. And substituting all these into there gives us 1.1 times 10 to the minus 9. And looking at the units, we're doing all of these in terms of meters, so this is meters, which is equal to 1.1 nanometers. Going to delta G of R star, delta G R star is equal to 16 pi gamma cubed Tm squared over 3 delta H of formation 1 over Tm minus T squared. And substituting into this gives us 1.2 times 10 to the minus 19. Now looking at the units here, we have 16 pi, no units, gamma cubed, which would give us joule per meter squared cubed, Tm, that's K squared, divided by delta HF, delta HF, that's squared. Sorry, I missed that. Delta HF squared gives us joule per meter cubed squared times this, which is going to be 1 over K squared. And K's cancel. That's meters to the 6th. That cancels. That's meters to the 6th. That is joules cubed, joules squared. So the joules squared cancels, leaving joules. So the unit analysis on this gives us joules. And you can think of this either as joules or joules per nucleating particle. Because if you remember in the derivation, we derived this for a single nucleus that's forming. So next we move on to the second part of the problem, in which we have a transformation that is obeys the Averroes equation. The value is n equals 5, and K is unknown, but we're given a data point saying the recrystallization is 0.3% finished after 100 minutes. So first we write the Averroes equation, which is y is equal to 1 minus x of negative k t to the n using our data point, 0.3 at 100 minutes, we get 0.3 is equal to 1 minus exp negative k t to the 5, or t, sorry, 100 to the 5. And rearranging that and taking the log of both sides, we get the natural log of 0.7 is equal to exp negative k 100 to the 5 or minus 0.35668 is equal to negative k 100 raised to the 5. K is equal to 0.35668 divided by 100 to the 5 is equal to 3.57 times 10 to the minus 11. So 3.57 times 10 to the minus 11. We have units on this K, and essentially we know that what goes inside of the exponential has to be unitless. So here we have minutes raised to the 5, which means K must have units of minutes to the inverse 5. So these units cancel out. 5. The rate is defined as 1 over t to achieve half the reaction, which means that we can take this equation and rearrange it in terms of t to solve for t, and we get t to the y is equal to log of 1 minus y divided by negative k, all raised to the 1 over n. So we've got that expression. So substituting in t 0.5 excuse me, is equal to natural log of negative 0.5, sorry, plus 0.5, this is 1 minus 1/2, divided by negative 3.57 times 10 to the minus 11, raised to the 1/5. Excuse me, we get 15.4 minutes. And then inverting that to get rate, we get 6.5 times 10 to the minus 2 inverse minutes as the rate. So that's solving the second part of the problem.